So we have created 3 different microservices so far, and we've been bringing them up individually using the go run commands. But now we want to see how we can automate this local development setup using some bash scripts and Docker Compose. So I'm going to start by creating this dev directory and an up script inside that. And the first thing I'm going to add here is the shebang to indicate that this is going to be a bash script. And we're going to do a few things here. So the first thing I'm going to do is build our containers and Docker file. Then we're first going to bring up our MySQL container. Then wait for this MySQL container to come up before applying the migration files. And then we're going to bring up the rest of the services. And before we forget, we want to make this script executable. So I'm going to change the permission of this up script to be executable. And to help us build containers and Docker file, I'm going to create a separate script and call it build. And I'm going to add this build script inside the same directory here. And again, the first thing I want to add here is the shebang. And in this build script, I'm going to make a directory called dev/dist that stands for distributables, as well as our build PID scripts that's going to store the process IDs of our build jobs. So because we have 3 different microservices inside our CMD directory, I want to do a go build of each of those main.go file. So I can iterate over each of those directories, ecom API, ecom gRPC, and ecom notification. And inside this for loop, what we can do is run our go build command. So cgo enable equal 0, go operating system will be Linux, our go arch will be AMD64, and we're going to go build our file inside the CMD directory and specify our file name. But our output is going to be in the dev/dist directory that we created above, followed by the same file name. So we are essentially building each of these main.go file inside the CMD directory and storing them inside this dev/dist directory. And along with this go build command, I am going to append each of the build PIDs with the plus equal sign and the $! So this $! is a special shell variable that holds the process ID of the last background process. And this will be used to collect background build jobs so that we can wait for these build processes to finish. And we're going to do the wait in this next for loop here. So we're going to iterate over those build PIDs. So I'm just going to echo saying process ID and just wait for this process IDs like that before we move on to the next step, which is building our Docker image. And in our Docker build command, we have to specify the name of the tag, which is going to be the name of the image. And I'm going to store this in a separate variable, call it image. And it's just going to be dhij.test/ecom latest. This will be the name of the repository. That's just going to be in my local environment. And this is the name of the image. And the tag will be latest. So I can specify this image variable as the name of the tag and specify my Docker file. And I'm going to call this Docker file.dev, and we're going to create this in a bit. But this is the Docker file we're going to define and use to create our image called ecom. And right after this line, we're just going to echo a line saying something like dev image built and just output it to dev standard error. So the next thing we want to do is create this Docker file.dev file inside our dev directory. So this is gonna be a very simple Debian Docker file, and I'm also going to specify the platform here. Since I'm using MacBook M2. And all we're going to do here is copy what we have inside our dev disk directory into the bin directory of the container. So I believe I have to add this equal sign here. So to give you an overview, what we are doing in our build script is run this go build command to store our output of this build command inside this dev disk directory. And we're copying the binaries inside this dev disk directory into the bin directory inside the container. So I'm going to give you a better idea of what's happening here by actually executing into the container. And the first thing we want to do is run this dev build script. But of course, we have to give this permission to be executable. So I'm going to run chmod +x and then run this dev build script to build our image. And this is going to say that it didn't find the dockerfile.dev because I'm running this from the root of the project. So I can do cd into dev and run dev/build or just the build script like that. And this is going to fail again. So I'm going to cd back into the root of the project and move this dockerfile.dev to the root here. And let's run dev build again. So now it works. And what we can try doing is docker run our image and go into the interactive mode. And now we're inside the container. What we can do is see what's inside our bin directory. So there are a lot of binaries inside here. But as you can see here, we see ecom API, ecom gRPC, and ecom notification inside our bin directory. And that's because, as you saw here, we're copying what we have inside the dev disk directory into the bin directory of the container. So we can exit out of this container, close this, and come back to the dev/up script. And right above our dev build script, I'm just going to echo saying something like building containers and just output this to standard error. And once we're done building our image, we want to bring up our MySQL container. And actually, I don't want to say I'm building containers here, but I'm just building my Docker file here. And to bring up MySQL container, I'm going to create a Docker Compose file inside our dev directory. And the first thing I'm going to do here is create our own bridge network. I'm going to call this ecom network and specify the driver to be bridge type. And the reason we want to do this is because it's recommended in the Docker Compose doc. And if you come to this Docker document on connecting a container to the default bridge network, I'm going to share this link in the description box, so feel free to have a read. But it says how the default bridge network is going to be used by default. And this is considered a legacy detail of Docker, and it is not recommended for production use. There is also a page comparing the difference between the user-defined bridges and the default bridge. So it says user-defined bridges, which is what we're doing, provide automatic DNS resolution between containers. So I'm not sure where it is mentioned here, but as you can see, it says the containers on the default bridge network can only access each other by IP addresses, but on a user-defined bridge network, containers can resolve each other by name or alias. So we don't want to be relying on IP addresses that can always change to reference other containers, but rather give each container an alias so that we can always reference to the same container inside Docker Compose. So we can now go back to our Docker Compose file and continue with defining our services. The first thing I'm going to add here is the MySQL service. And I'm just going to paste what I have already prepared to save us some time. But again, we specify the ecom network that we specified up here. Add this platform to be AMD64. And we're going to be using the MySQL container version 8.4. provide the port mapping so that we can access this container on port 3306, as well as some of the environment variables. And below that, I'm gonna add the ecom gRPC service. And again, it's pretty much the same. We have the network's hostname, platform, the image we're using, as well as the command. We have the port mapping environment variable and the dependency on the MySQL service to make sure that MySQL container is running before this starts up. And there's actually one change that we have to add in our particular case. So if you see here, we're specifying the DB address to be MySQL colon 3306. So as I mentioned earlier, we can reference the other service, in this case our MySQL service, using its name because we're using our user-defined bridge network. So we want to pass this DB address into our ecom gRPC service so that we can use this when we instantiate our database. Right now we're using a hard-coded localhost 3306. So we want to pass in this DB address environment variable through the main.go file. So what we can do here is add this environment flag DB address with a default value of localhost on port 3306 and pass this DB address, which is a pointer type, into this new database method. And of course, I would have to dereference this. And then we can move into db.go file, take the DB address string as an argument. And down here, I can do fmt as printf and pass this DB address and use it inside our string like this. And that's just one change that we had to do for this particular case. And if you're using an environment variable in your container, you would have to do something similar to that. And below our ecom gRPC service, I'm going to add two more services. Of course, our ecom API and the ecom notification service. And I'm just pasting this here because they all follow a similar structure. And the only thing I want to point out here is that we are using the same image for the ecom API, ecom notification, and the ecom gRPC. The only difference between the three container is the command that we are running. Of course, we are going to be executing different command for each of the services. And as you might recall, we have these binaries inside the bin directory because we copied over from dev.dist into the bin directory of the container. And now that we have defined our Docker Compose file, we can come back to our up script and we can bring up our MySQL container by running a command that looks like this, but our compose file is .yaml with an A. So we're going to run our Docker Compose in a detached mode and specify the MySQL container that we want to run. And we want to make sure that this MySQL container is up and running before we attempt to apply the migration files, because otherwise, of course, it's going to fail. So one way we can check if the MySQL container is running is by doing something like exec MySQL and run the MySQL command with a username and password. And of course, this is not a good practice, but I'm going to do it for the sake of simplicity and specify our database name, which is ecom. And we actually specified this in our Docker Compose file here through our environment variable. And we can really just run a command like select one. I'm actually going to have this in a single quote like this. But the problem with this command is that this is only going to run once. So I'm going to define a separate helper function, call it wait for, and pass this command as an argument to this function. And I'm going to define this function up here, call it wait for. At the end of this function, I'm just going to return 0, and I'm going to have a variable called attempts. And what we're going to have here is a while loop and it's gonna run an eval command on the argument that's passed in. And I'm gonna go over what this means in a bit, but I'm first gonna type them out. So we have a while loop that's gonna run this eval command, and all this eval command do is really just execute the command that's passed in as argument. In this case, this argument is going to be docker compose command that we pass in as the argument for this wait for function. So this is going to execute that command, and we are negating this eval command, of course, because we want to iterate again if this fails. So if this command fails, we're gonna iterate again, and we're redirecting the output to /dev/null, meaning we want to get rid of the output. And this part means that we want to redirect the standard error to where the standard output is going as well, meaning we want to discard both the standard error and the standard output into /dev/null, because we don't need the output from running that command. And inside this while loop, we are going to check if the attempts is greater than 99 or any number that you specify. If it is greater than 99, I'm just going to say timed out, waiting for that command, and just return 1. Otherwise, I'm going to increment the count of attempts by 1 and sleep for 3 seconds before trying again. With this, we're going to be able to run this command multiple times until we're sure that the MySQL container is up and running. The next thing we want to do is apply our migration files, and we're going to create a separate migrate command here as well inside our dev directory. Probably have this leftover dev directory from my previous take, so I'm just going to get rid of that. And inside the dev directory, I'm going to create this migrate script, and let me paste what I have prepared to save us some time. So we set this -e flag to ensure that the script will terminate immediately if a command fails, and this will make our script more robust. We have these variables that we use in the script with some default values, as well as the base docker command. And all we're doing here is running this migrate image. And the only thing I want to point out here is the volume mount here. And all we're doing here is mounting the DB directory in our current directory, which is referencing this DB directory in our project that has all our migration files. So we're mounting this DB directory into the /db directory of the container. And because we mount this DB directory inside the container, when we run this docker command, we can specify this path to our DB migration file, and the container is going to know where our migration files are. So without this volume mounting, it's not going to have access to the migration files. So let's skip this part for now and look at this last command here. So we're running this migrate container, specifying the migration files, and we have this database string. And last, we have this command that's passed in as an argument. So this can either be an up or a down command. So we can run the script with something like dev migrate up or dev migrate down. And while we're here, we can make this migrate script executable. And if we pass in the create command as its argument, then we're going to run a different command on the container with something like create with an extension and the directory of the DB migration, as well as the name of the migration file. So this is going to look something like dev migrate create add users, and this will be the name of the DB migration file. So that's all we need for the migrate script. I'm going to come back to our up script, and we already have this command here. The only thing I want to add here is some echo saying applying migrations. And once we have applied these migration files, we can now bring up the rest of the services. So we can say bringing up services, and we're going to type docker compose up on our docker compose file. And before we test this up script, I want to create a down script to bring down all our containers down as well. So I'm just going to run this docker compose down command, and also remove our dev dist directory to clean up. And lastly, an echo command saying removing containers or something like that. So now that we have our dev up and the down script, I can run this up script. And as you can see, this didn't take too long. And if we go through the logs here, we can see we're building the containers. And then we're bringing up the MySQL container first before applying the migrations and bringing up the rest of the services. Now let's make this dev down script executable and run the dev down just to clean up the containers we've just brought up. And that's all working fine as well. And that's all I have for this episode. And this is going to be the last episode of this series. And I'm going to come back with a bigger project in the future covering how we can create and deploy production-ready apps. Let me know in the comments if you have any questions. Thank you all for watching.